Okay, I figured it out. What I did figure out was that we made this substitution wrong, or I guess I did. This should have been this plus 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 plus. All right, wonderful. Oops. Anyways, this is the solution. I can prove it because it's here. So here's what our figure looks like. Here's the actual figure. Pretty similar, right? 0 to 10, negative 10, peaks, waves, stuff like that. So this is our solution with our V in red and our response in blue. It's just kind of like a lagged sinusoid. Cool. Um, cool. I wish I could ask if there were questions about that, but I can't. So, anyways, that's problem five. Notes for problem five for the final that I wrote. I'm not going to make you solve a circuit in my final. I'm going to give you the differential for it. So it's not going to be, all of this stuff that we had to do. Don't worry about it. You might have to worry about it for the actual final, but for the lab final, not necessary. Cool. Okay. Question six, not great. This code doesn't seem to work as written. Okay, sure. So we'll just copy it. Okay. When I was doing problem six in class, I noticed that it just straight up doesn't work as intended. But we'll talk about debugging for now. So if we just run this the way it is, it'll tell us line 14, incorrect use of equal operator. So here's line 14. Okay, so what comes after an if statement? Generally should be an equals, a double equal sign, right? This is a logical check. So for m is equal to 1 to n, so n is my number. If the mod of n and m is equal to 0, it's prime. So what does that do? It's saying, okay, if we ever divide these numbers and it's equal to 0, prime is true. Assume m is prime until proven otherwise. Oh, this is really weird. Okay, and we'll run that. Enter an integer. 5. Factors found. Undefined function or variable factors found. Line 27. Here. Factors found is equal to factors found plus 1. This looks like a running sum. Hopefully you've seen running sums before. So this variable is just now factors to factors found. So I'll run that. 6. Cool. Its prime factors are 1, 2, and 3. 20. 1, 2, and 5. No, I guess it does work. Are those other prime factors of 20? I guess so. I guess technically is one prime. I don't know. That's a stupid question. That's not related to this problem. Anyways, the two things that we found here are generally after if statements we have logicals, and a logical check is double equal sign, not single equal sign. And then this variable, hopefully we can recognize this as a running sum. Factors is equal to itself plus one. And before it was like this, which is incorrect. There's no variable factors, or sorry, there's no variable found. So that's just a typo. So that goes out that. And 9, yeah, it pulls it out. So this is the debug. There is a debug problem on the final. It's not terribly hard, I don't think. Stuff like this. I modeled it after common mistakes I'd seen in lab. So if you learned from your lab, hopefully you can do the debugging. It's structured very similarly. It tells you what the problem should do, how it does it, etc. And then there's some things wrong with it. Okay, problem 7. Ooh, yikes. Looks like another another job for MS Paint, honestly. We'll save this as Prob 1. Don't look at my files, please. Um, and we'll take this. That's not the folder I want. This is the folder I want, or the thing. Okay, so let's solve this. What we're going to do is we need to solve this problem for IX. And what we really want to do is we want to solve it for IX using a system of equations. And we're going to do that by doing some current analysis at this node right here. So we're going to assume some current directions. Let's assume this is going on, this is going on, this is going on, and then finally Ix is here. So we can kind of write we'll give these names. We'll call this I1, I2, we'll call this one I3, and Ix. So, oh, that is low resolution. Okay. Okay, let's see what I1 is. So we'll just call this node voltage V. So let's look at I1. I1 is a difference between, and we'll just set this as a relative ground. So we'll just say this voltage is 0 at the bottom. It doesn't really matter what it is, so we'll just call it 0. Okay, so this first node here is the voltage difference between here. So let's use a different color. Let's use purple. Here and here divided by its resistance. So that voltage difference is, if this is at 25 volts, so this is 0, add 25 volts here, so we must be at 25 volts. 25 volts minus V. This is the voltage differential, and that is divided by 10 ohms. So that's I1. I2 is kind of a gimme, right? We just know that's 1 amp, so I2 is 1. I3 is equal to, I3 is equal to the difference in voltage between V and 0, so it's V, and it's over a 20 ohm resistor. And then we have finally Ix. And that's obviously what we're solving for, so we're not going to do anything special to it. Okay. Lastly, what we have is we can kind of come up with an equation that relates V and Ix, and that's from the orange, this current, and what that says is Ix is equal to the difference in voltage here, so this is at 0, this must be at 50, and so this is at V, so it's V minus 50 divided by 20. Awesome. So, what is our general equation here? We know that I1 plus I2 is equal to Ix plus I3, right? That's kind of how we assume these currents to roll. So I1 plus I2 is 20, let's go back to block. 25 minus V over 10 plus 1. So this is I1 and I2. That's equal to I3 V over 20 plus Ix. In our second equation, we have Ix is equal to V minus 50 over 20. Let's rearrange these into kind of a form that looks like this. So what we want is like Ax plus by is equal to C, right? We want this kind of format. And so in this case, our variables are V and Ix. So we'll arrange it. So let's say, we'll split up this fraction. We'll get 25, God, terrible 5, 25 over 10 minus V over 10 plus, we'll say 1 is 10 out of 10. And we'll say this is minus V over 20. While we're here, let's casually change this to 2V over 20. And then we'll subtract Ix, and all that's equal to 0. From here, we'll kind of simplify some terms. So this is negative 2V and negative V, so it's negative 3V over 20 minus, we'll put a 1 there, Ix is equal to, so it doesn't have a term on it, 25 over 10 and 10 out of 10. So this is 35 out of 10. On this side it's negative, so we'll do that. Cool. In our other equation, we have Ix is equal to V over 20 minus 50 over 20. So a pretty simple one here. We'll just move this to the other side, and we'll do that by opening up some more paper. So we have negative 1 over 20v plus ix is equal to negative 50 over 20. So, can I make this bigger? By very small amounts at a time. Yikes. Here, let's do this. Oh god, super yikes. Oh, that's way okay. I'm stupid. So we have these equations. We'll copy that. We'll put it here. Copy that. We'll put it here. This can be represented in the following way: negative 3 over 20, negative 1, negative 1 over 20, positive 1, v ix is equal to negative God, 35 over 10 and 50 over 10. That looks awful, but you know, you get the point. So, you know, we'll come back to MATLAB. Let's save this as practice 7. And what do we have? Negative 3 over 20, negative 1. A is equal to negative 3 over 20, negative 1. Negative 1 over 20, positive 1. Negative 1 over 20, positive 1. B is equal to negative 35 over 10. Oh, yeah. If you're confused, we're saying this is A, x vector is equal to B. So B is negative 35 over 10. Yeah. 10, column, negative 50 over 10. And, wait, was it 50? 20. Yikes. 20. Then finally, x is equal to inv A times B. Cool. Yikes. Let's do this. Okay, so we get 30 and negative 1. How did we order this? It was v and then ix. So if we're solving for ix is negative 1. And if we look at this solution, ix is equal to negative 1. Awesome. We did it. God, get rid of that. We don't need that. So here. Oh gosh. Negative 1. Cool. So that's practice problem number 7. Are there more than that? That was the last one. Okay. Notes about the final. Let's do this. Okay, notes about the final. Things to be familiar with. Forward Euler's method. Definitely. Definitely. Some stuff there. OD 45. Simple use, single differential equation. PID control. This is like lab 7, or I think this is lab 7. Implementing PID control in use with Euler's method. That's really important. This has some subnotes, I would say. Understanding how to calculate an error term. Understanding how to define that term's integral representation and derivative representation numerically. That's really important. Cool. General coding, indexing, and debugging. And using code from lab 8 and 9 to plot a spectral analysis. I would be really comfortable with that. How, you know, the final, notes about the final during normal lab time, no talking, please, open internet/book, notes, 3 hours. Duration, I think there's 9 problems. Hopefully on a MATLAB grader. Hopefully. Oh, fuck you. Hopefully. Cool. So, topics on the test, which are basically the labs. Oh, no P Spice/Simulink stuff. So don't worry about studying that. Just all just general MATLAB coding. Normal lab time, you know, Friday, March 15th. Yeah. One last thing to say about that is please don't cheat. You know, open internet is a very, I know you can't talk, but if you have the internet you can talk digitally. Man, is that not worth it. Wow, what an awful thing to do, to be caught cheating on a lab practical final, and to be, just don't cheat. I'm gonna throw the book at you. So don't do it. And yeah. Good luck. This concludes this video. I'll put this on YouTube. Right now it's what, 3 p.m. So yeah, if I remember anything else that I want to say, I'll email you. But this should pretty much be it. Maybe I can make this bigger, and I'll probably upload this. But yeah, cool. Good luck.